All right, super quick. Let's talk about power. Power, a word that is familiar to many people and means many different things to many different people. We can talk about political power, we can talk about social power, we can talk about buying, lots of different power. Physics, you know about power for physics. Power is very closely related to work because power is simply the rate at which work is done. Anytime that the word rate is used, you need to basically understand that the word rate means we got a fraction involved. And many times when we're talking about rates in physics, time is going to be on the bottom. All we're doing is we're doing something and we're trying to figure out how long it takes us to do that thing. And the ratio of the thing we're talking about divided by the time it takes gives us the power. We can talk about an interest rate, an amount you're charged per dollar. That per means if there's a fraction bar. We can talk about the rate of speed. That's meters per second. Lots of different rates here. So power is the rate at which work is made. Oh, cool, tractor. Let's do it again. One more time. Ready? Is that a tractor sound? Try it again. Maybe this one. I don't know how to make a tractor sound. You're gonna have to do it on your own. Ready? I'm gonna give you one more shot, and you can make your own sound on your own. Okay, ready? I'm gonna give you a 3, 2, 1, go, and on go, I'm gonna do it. Ready? 3, 2. You have to make the sound. Ready? 3, 2, 1, go. Okay, good job. I heard you. So this is the equation for power, and it goes in here. Now really, when we say power, we're going to talk about this. We're going to say power is work divided by time. But remember that here's the equation that we talked about before. Work actually equals force times distance. So we could just substitute force times distance in for the work, and we could say force times distance divided by time, depending on what the problems give us. Now, I want you to see something here that you're going to get confused. So very important, right? First of all, this W right here stands for, let's see if I can type this with my mouse really bad, but you can read that, work. The W in the equation is work, both the work equals force times distance equation and power equals work divided by time equation. The W in the equation means work. This W right here is not work. That W means watts, right? Big old W here, capital W. It's the abbreviation for a unit, which is named for a person. Isaac Watts? No, he was a songwriter. Who is that dude's name? I don't know. Go look up Watts. This is the dude's name. But watts is the unit for power. You might go, oh wait, I've seen that before. And there might be, ooh, ready? Joke coming up, ding, 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 ding. There might be a light bulb going off in your head, right? Why is that a joke? Because where you might have seen the unit watts before is the power of a light bulb. You might, well, back in the incandescent days, you might have bought a 60-watt light bulb. Now they're like 13 watts. But it's the amount of electrical power that's used, and there's work being done there. We're going to talk about that concept. We're not going to talk about electrical power right now. We're going to talk about mechanical power. So power is work divided by time. Work is still in joules. Time is still in seconds. All right. So that's the equation for power. So you might have a problem that looks something like this. Dirt simple. This is an insulting problem. I don't have a voice today. A machine performs 500 joules of work. That's your work. Over a period of 100 seconds. That's your time. How much power does the machine have? Power is work divided by time. Work is 500, time is 100, 500 divided by 100 is 5 watts. We get 5 watts of power out of this deal. Super simple. Let's look at a different problem. It's not quite so simple. This says an electric motor lifts an elevator 9 meters, that's our distance, in 15 seconds, that's our time. All right, so we go distance, time, by exerting an upward force of 12,000 newtons. So there's my force. Right? What power does the motor produce? We want to look for power. Power is P in the equation. Right? So let's talk about how to solve this problem. All right, so here we go. We said we had distance, we had time, we have force, and we're looking for power. That's power if you are from Jamaica, not really. Power. So people go, okay, cool, yeah, power. That's work divided by time. That's awesome. But wait a second, time out. I have the time, check, check. What about work? Yeah, well, this is where we got to use our other equation. We know work equals force times distance. So we can just replace force times distance, or replace work with force times distance. And now we got it. We got the force, check, check. We got the distance, check, check. We got the time, check. All right, so there's our equation. Now we can just plug in numbers. Force, 12,000. Distance is 9. Time is 15. So we just go, turn it on first. 12,000 times 9 equals 108,000 divided by 15. 7,200. Power equals 7,200 watts. 7,200 watts. That's a lot of watts. That's a lot of power. I got a joke. What's the energy for power? The answer is yes. I know, that joke sucked. Maybe you didn't even get it. Just think about it for a little while. Let's do one more example with power. You might have problems like this. I want you to look back up at this one we did. You might have a problem that says exactly this, but it'll give you some more information. So let's say that this problem actually says how much work, or it says, let's imagine that instead of work, it's asking for power, right? And it also gives you a time. You gotta have time to calculate power. Let's say that it does this in 8 seconds, let's just say, okay? And it says, what's the power? Well, we would simply do like this. Maybe let's come down here and do this. We would kind of do the same thing here. Power equals work divided by time, right? And we knew that work is force times distance divided by time, because they don't directly give us the work here, unless they said 5880 joules of work in the problem, in which case you just do 5880 divided by time. In this case, we know that the force is the weight, and the weight is mass times gravity, so I can plug that in instead of the force, right? Times the distance. So we did all that. We did all that. We got the work. We did mass times gravity times distance. We did 5880. So here we would go 5880 is what we would get from all that, from that problem. And then we would divide by the time. And let's just imagine they gave us a time of 8 seconds. So here we go, 5880 divided by 8. Clear. 5880 divided by 8 gives you 735. 735, this is power. The unit for power is watts. 735 watts. All right, so that's basically how to work power problems.